Okay, let me ask you something. The water you drink, the air you breathe out, the fuel in your stove, what do they really have in common? It might sound like a riddle, but they're all built using the same secret code. Today, we're going to crack that code. We're talking about molecular compounds, the invisible glue that pretty much holds our entire world together. So, let's dive right in by looking at some things you come across, well, every single day, probably without even thinking about it. Seriously, think about it for a second. A simple glass of water, the carbon dioxide you just exhaled, and maybe the methane gas that cooks your dinner. What is the one big thing that connects them all? The answer? They are all what we call molecular compounds. And honestly, once you get what that means, you start to see how our world is put together on a fundamental level. It's pretty cool. So what exactly makes something a molecular compound? Well, to figure that out, we've got to get into this super exclusive, but actually very friendly electron sharing club. Let's unpack the special bond that holds these amazing molecules together. So here's the deal. A molecular compound happens when at least two nonmetal atoms, we're talking things like hydrogen, oxygen, carbon, get together and bond by sharing electrons. And that word sharing, that's the whole secret. It's how these atoms get stable and just happy. And that special sharing bond, it has a name, of course. It's the covalent bond. This is really the engine that makes molecular compounds work. You can think of it like a chemical handshake, a partnership, where atoms agree, hey, let's share our electrons so we can both be more stable. Now, this whole idea of sharing is a really big deal in chemistry. See, covalent bonding is a true partnership. It's totally different from an ionic bond, which is more like a giveaway. One atom just hands over an electron to another. So you've got sharing on one side and taking on the other. Two completely different ways for atoms to connect. All right, so now that we know what these compounds are and how they're made, let's get practical. It's time to learn how to speak their language. And that means we need to learn how to decode their names. And this right here, this is basically your cheat sheet. It's all about these Greek prefixes. Mono for one, di for two, tri for three, and so on. They tell you exactly how many atoms of each element are hanging out inside that molecule. Let's actually put this to the test with a real example, N2O5. Okay, first up, we see the N, that's nitrogen. The little 2 next to it tells us there are 2 of them, so we grab the prefix di. Boom, we have dinitrogen. Next, we've got O for oxygen, and the 5 tells us to use penta. We just tweak the ending a bit to get pentoxide. Slap them together, and you get dinitrogen pentoxide. See? It's really just a logical system. But why do we even need these prefixes? I mean, why is it so important? Well, it's because nonmetals are super flexible. They can team up in all sorts of different ways. Take carbon and oxygen. They can form CO, carbon monoxide, which is really dangerous, or they can form CO2, carbon dioxide, the stuff we breathe out. Those prefixes are absolutely crucial for telling these very different and very important molecules apart. Okay, so beyond their names, what are these compounds actually like? What's their personality? How do they act in the real world? Well, they do share some common traits. For one, they usually have low melting and boiling points. Just think about how easily water turns into steam, right? Because of that, they're often gases or liquids when it's just room temperature. And here's a big one. Since their electrons are all tied up in those sharing partnerships, they're really bad at conducting electricity. So let's bring this all back around. We've talked about definitions, we've gone over naming rules, but why does any of this really matter? Well, the impact of this simple covalent bond is, and I'm not exaggerating, absolutely immense. I mean, just think about these heavy hitters for a second. Water, H2O, is literally the foundation for all life as we know it. Carbon dioxide, CO2, is at the heart of breathing and our planet's climate. Methane, CH4, is a huge source of fuel. All of these essential, world-shaping substances are built on that one simple idea of sharing electrons. So at the end of the day, this whole thing about atoms sharing electrons, it isn't just some boring concept in a textbook. It is the fundamental process that builds the world around us, from the water in the oceans to the fuel that powers our homes. So it kind of leaves you with a final thought, right? How can a bond that's based on something as simple and gentle as sharing be powerful enough to create the stable, essential stuff that makes our entire world possible? It's just a really amazing testament to the elegant power of chemistry.